Okay, finishing up chapter 3 here with inequalities in one variable, we're looking at section 3.3, which is absolute value inequalities. So inequalities with absolute value, what we have to do is we have to first rewrite them without the absolute value sign, and then we solve them. So what we have are two possible cases. We have the case where we have the absolute value of x is less than a, or the absolute value of x is greater than a. That's after we've already simplified it down as far as possible till we have the absolute value on one side and then everything else to the other side. Now, when we have this, if we have the absolute value of x is less than a, what we need to do is rewrite that as negative a less than x less than a. And again, if this is less than or equal to, we just put those in there as well, less than or equal to, okay? And so when we have less than a value, some a, then it's going to be between negative a and positive a for our value of x. Now, if x is greater than a, then we end up with an or statement. So this one gives an and, this one gives an or. So this one case, x is going to be less than negative a, or x is going to be greater than a. Okay, and again, it's going to be working for the same thing with greater than or equal to. So this will be, it could be less than or equal to or greater than or equal to. So you have to really pay attention to if those are strictly less than, or it could be less than or equal to. All right, so like I said, what we have to do is we have to isolate that absolute value on one side of the inequality using all the things we've done previously, the addition method, etc. And then we get the inequality or the absolute value with the variable by itself on one side and then all the numbers on the other side. Now, remember what absolute value means when solving problems. Evaluating absolute value will give you a positive value. So absolute value of x is always going to be greater than or equal to 0 in all cases. So if we get an absolute value that's going to be negative, that means there's going to be no solution. So they're going to give you some that you're going to end up with no solution because, they'll say the absolute value of x is less than a negative 2. Okay, well, guess what? You can't do that, and so you don't even have to simplify any further than that. You can say, okay, well, that's no solution. Okay, if I can write here. Okay, and so once you get something that just doesn't make any sense, absolute value always has to be positive. You just say no solution. So what we're going to do now is we're going to work problems out. What we're going to do is isolate the absolute value on one side, and then we're going to use these two basically identities where the absolute value of x is less than a, we write it as a tripartite. If the absolute value of x is greater than a, we write it as an or statement. Okay. All right, so our first one, what we're going to do is, again, solve the absolute value and then graph it and then write the solution in interval notation. So kind of what we've been doing all along. Now, this one we can't simplify anymore. So we have an absolute value on one side and a number on another side. And so with the less than, we're going to rewrite this as a tripartite. Okay, and so this piece is going to be, quote, the x part. And so we're going to have x minus 7. We're going to say, well, that's less than 3, or greater, yeah, less than 3, but greater than a negative 3. So this one gives us a tripartite when we have a less than. And so we just have to put the negative 3 on this side and then drop our absolute value. And now we just solve. So now we add 7 to all three sides. Okay. So 7 minus 3 is 4, and that's less than x, and that's less than 10. And so now, remember, with tripartite, we have to have an intersection. So here's a 4, here's a 10. So x is greater than 4, so it's an open circle. But x is less than 10, that's another open circle. And our intersection is in between there. So it's going to be an open circle at 4 to an open circle at 10. And if we write that in interval notation, we're going to have a parenthesis 4, comma, 10 in parenthesis. And so that would be our solution in interval notation. This would be the actual graph solution, and then this would be our inequality solved. Okay. So less than gave us the tripartite. Greater than or equal to is going to give us the or. And so what we do is we drop the inequality sign and say that's greater than 3. So we'll have x minus 3 is greater than or equal to 3. or, and now what we say is it's going to be x is less than or equal to a -3. Okay, so we're going to have both pieces. Oh, actually, it's x minus 3. I'm writing all kinds of stuff wrong. I have too many 3's here. I get lost. All right, so this is going to be x minus 3 is less than or equal to a -3. So I had to put that extra -3 there from the original value here. Now, or, remember, that's a union, so we're going to have two parts probably. And so that's going to be add 3 here, add 3 here. So x is going to be greater than or equal to 6. Here we're going to add 3, and x is going to be less than or equal to 0. Okay, so what does that look like graphically? We have our 6 here, we have our 0 here. So it's going to be less than or equal to 0. So that's going to be solid less than or equal to. And here it's going to be greater than or equal to 6. So solid to the right. And now we're going to have two interval notation pieces separated with a union symbol. So it's going to go from -infinity to 0, union 6. Oops, these are brackets, not parentheses. Don't forget, when you have the closed circle, it's a bracket. And then it's going to go to positive infinity. So closed circles greater than or equal to, and they become brackets. And so then that should be our solution to this absolute value inequality. All right, so now we have them where we have a little bit more work to do. We just don't have an absolute value on one side and a number on another. We actually have to do some manipulation first. Well, the first thing we can do is we're going to get rid of that 1. So let's subtract 1 on both sides. So when we do that, we get 2 absolute value of x minus 1 less than or equal to 8. Now we need to get rid of that 2, so we're going to divide both sides by 2. So we get absolute value of x minus 1 less than or equal to 8 divided by 2 is 4. Now we've got it in the form where we have a less than or equal to with absolute value. That's going to give us a tripartite. So what's going to happen is it's going to be a -4 less than or equal to x minus 1 less than or equal to a +4. Now we have to solve for just the single variable in the middle, which is x. So to do that, we have to add 1 to all 3 parts. And so -4 plus 1, -3, less than or equal to x, less than or equal to 4 plus 1 is 5. Okay, so now we graph this. Remember, tripartite, we have to have the intersection. So it's going from a -3 to the +5. So now it says x is greater than or equal to a -3. So it's going to be a closed circle to the right. And here x is less than or equal to 5. So closed circle to the left. And our intersection is there. So it's really a closed circle from -3 to the +5. And so that would give us our interval notation from -3 to the 5. Okay. And again, what we had to do is we had to isolate the absolute value by itself. And so we kind of had to use PEMDAS in reverse. So that means we had to get rid of the addition or subtraction first. And then after that, get rid of the multiplication or division next. So the same thing happens on the next one, if you notice. So pretty similar. So we need to get rid of that 4 at the very beginning. So those cancel. We have 3 absolute value of x minus 1. Absolute value, then greater than or equal to 10 minus 4 is 6. Now we'll divide by 3. So the absolute value of x minus 1 is going to be greater than or equal to 2. All right, remember with greater than or equal to, that's going to give us an or. So we're going to have x minus 1 greater than or equal to a 2, or x minus 1 is going to be less than or equal to -2. Okay. All right, now we just solve. So we add 1, x is greater than or equal to 3, or now we add 1, x is less than or equal to a -1. All right. Remember with, oops, let's start over here. Draw a better graph than that. So we have a -1, we have a +3. So x is going to be greater than or equal to 3. So it's going to go that direction. Here it's going to be less than or equal to a -1. It's going to go that direction. And so if we write that in interval notation, we're going from -infinity to the 1. So it's going from -infinity to the -1 bracket union, because we have or, then we have a bracket 3, and then we're going positive infinity. Okay, so that would be how we get that one solved. All right, what about this one? Well, these are going to start getting a little more in depth, because now if we see here we have a negative, and so we're not going to just divide by a positive, we're going to divide by negative, which means our signs are going to have to change eventually. And so when we do these, again, we need to get rid of that 5 first. So we'll add 5. So -2, absolute value of 3, x -6, absolute value less than -6, so it's -3. Okay, and then now we're going to divide by -2. And remember, that means this is going to change to greater than. So we have absolute value of 3x -6 is greater than, now -3 divided by -2 is a +3/2. Now with this, the greater than, that's going to give us the or, and so we're going to end up with 3x -6 is going to be greater than 3/2, or 3x -6 is going to be less than, and it's going to be a -3/2. Okay. All right, so we have to simplify this one. And when we do that, that's going to say, okay, we'll add 6 to both sides. So we have 3x is going to be greater than. Now 6 has to have the common denominator of 2, so we need to multiply by 2/2. So that's going to be 12 plus 3 is going to be 15 divided by 2. Okay. Now we need to get rid of the 3, so I'm going to multiply by 1/3, and you'll see why I do that here in a little bit, because if I multiply by 1/3, then those still cancel, but now it's in a form that's easier, because if I said divide by 3, then I'm going to have to change to multiply by 1/3 anyway, and so I just switched it to multiply by 1/3 at the beginning, so then 3 will go in here once, 3 will go in here 5 times, and so x is going to be greater than 5/2. Okay. Now what about here? Well, again, we're going to have to add 6. And so we have 3x. Now again, we have to kind of have a common denominator, so multiply by 2/2. So that's going to be 12 minus 3. So that's going to give us, it's going to be less than, it's going to be 9/2. Now we're going to again multiply by 1/3, because we need to have to do the same thing on this side. Now 3 will go in here once, 3 will go in here 3 times, and so that says x is less than 3/2. All right, and again, this is or. So this is going to be one where we have fractions, but fractions really don't bother us at all. But which one is bigger here? Well, 3/2 is smaller. That's only 1/2. That's going to be 2/2. So that's 3/2 over here. That's 5/2 here. So less than 3/2. So open circle to the left. Greater than 5/2, open circle to the right. And so if we write that, well, let's write it up here so we don't run into room down here. That's going to go from -infinity to 3/2. That's going to be open, so it's a parenthesis union. Now we're going to have 5/2 to positive infinity. And again, open circle, so it's going to be a parenthesis. And so that would be our interval notation. If I can write it, that would be our graph. And then this would be kind of our solution, greater than 5/2 or less than a -3/2. All right, so similarly on this one, we have to do the same kind of things. And when we get done, you see we're going to divide by -4, so we're going to have to switch our sign again. But first things first, let's subtract 4. So we have a -4 absolute value of -2x plus 6 absolute value greater than -4, so it's a -8. Now we're going to divide by a -4 on both sides. So that, again, change a sign to less than. On the right here, we'll have 2. On the left, we have absolute value of -2x plus 6. Okay. Now, this being the less than, that's going to give us the tripartite. So we're going to go from then -2 less than -2x plus 6 less than 2. So the right part over here is the same, and then we just add this greater than a -2 here, changing the sign of that. Now we have to solve for the x here in the middle, so let's subtract 6 in all three parts. So -2 minus 6 is -8, less than -2x, less than -6 plus 2 is going to be a -4. Now we divide by -2, and what does that do? Well, that's going to change our signs in both places. So that's going to be greater than, that's going to be greater than. -8 divided by -2 is a 4. Our x stays in the middle. -4 divided by -2 is a 2. Now let's see where that intersects. So we have a 2, we have a 4. So here it says x is less than 4. Okay, so it's an open circle of 4 to the left. Here it says x is greater than 2, so open circle at 2 to the right. And they do intersect between them. So open circle 2 to the 4. And so that's a parenthesis 2 comma 4 in parenthesis. Okay. So that kind of shows you the difference where we have one is a or statement when we get done because of the greater than, and the other one became in tripartite because we had the less than. All right, now basically all we're just going to do is just keep working problems until we, have a few under our belt. So what do we have here? Well, this one looks like we're just going to subtract 14 from both sides. So when we have that, that gives us 5, absolute value of 4x minus 3, in the absolute value, then less than. Now we have, that's a 14. So minus 14 plus 4, minus 10. Now we divide by 5. So absolute value of 4x minus 3, absolute value less than a minus 2. Okay. And so now we have a less than. So what it's going to be is we're going to have the opposite of this is going to be a 2. That's going to be less than 4x minus 3 is less than a -2. Okay. Because we have our a here, and then we have the opposite of a over here when we do that. Now we're going to add 3 to all three places. And so it's going to be 5 is less than 4x is less than 1. Now we'll divide by 4. And so 5/4 is less than x is less than 1/4. Now let's see what that does here for our graph. Well, that's going to be 5/4 is over here. 1/4 is going to be over here. So it says x is greater than 5/4. Well, and it's going to be open circle to the right. Here, x is less than 1/4. It's an open circle to the left. Where do they intersect? They don't. So there's no solution. Okay. And so that would be what we get for the answer on this one. And I did all that work, but guess what? At this point right here, we could have saw that absolute value is less than -2. And so if we had noticed that, at that point there, we could have said no solution as well. And so I wanted to kind of show you that if you don't notice it, you can keep working and it gives you a thing where, there's no intersection and so there's no solution. Or if at this point here you notice, hey, absolute value is less than a negative number, well, that's not possible, so there's no solution. And so there's two ways to work this one, right away or, the long way, I guess you could call it. All right, how about this one? Well, this one we're going to subtract 7. So we have a negative 5 times absolute value of x plus 6 less than or equal to, and now we have 15. So now we're going to divide by negative 5, divide by negative 5. What happens when you divide by a negative? That becomes greater than or equal to. Now here this is going to be a negative 3, and this is going to be absolute value of x plus 6. All right, so this is going to give us an OR statement. So we're going to get x plus 6 is greater than or equal to a negative 3, or x plus 6 is going to be less than or equal to a positive 3, because it's going to be less than or equal to the opposite. Now, subtract 6. X is going to be greater than or equal to a negative 9, or subtract 6, x is less than or equal to a negative 3. Okay, now remember, this is OR, so let's graph both of these. So we have a negative 3 here, negative 9 here, so it's going to be greater than or equal to this one, so it's going to go that way. This is going to be less than or equal to negative 3, so it's going to go that way. Well, remember, with OR, it's in what's in this one, or what's in this one, or what's in both. Well, guess what? This one goes all the way from negative infinity all the way to positive infinity. And so, if we wanted to, we could write negative infinity to positive infinity if they wanted it in that format, where we could say all real numbers. Kind of depends on how they're going to ask you to write it. But if they ask for the interval notation, that's going to be what it is. But that just means it's all real numbers. It's going to be the whole number line. All right, a couple more here. What do we do here? Well, the first one, we're going to subtract 4. We're going to get rid of that. So that gives us a minus 6 absolute value of minus 6 minus 3x in the absolute value less than or equal to, and that's going to be a minus 9. Now we have to divide by a negative 6 and divide by a negative 6. Well, when you divide, that changes that to greater than or equal to. And now what we can do is we can reduce this. That's going to give us a 2. That's going to give us a 3. So that's going to be a 3 halves. And that's going to give us a minus 6 minus 3x. Okay. Now, because of the greater than or equal to, that's OR. So what does that tell us? Well, we have minus 6 minus 3x is going to be greater than or equal to a positive 3 halves. Or minus 6 minus 3x is going to be less than or equal to a negative 3 halves. Okay, because it's going to be less than or equal to the opposite. Now we need to solve. Okay, well, this time I'm not going to take the 3x over here and do all the extra work. I'm just going to say let's add 6 to both sides. So then I have a negative 3x is greater than or equal to. Well, now I have to get a common denominator, which is 2. So that's going to be 12 plus 3. So that's going to give me a 15 over 2. Now here I'm not going to divide because I see if I divide a fraction by another thing, it's going to be more complicated. So I'm going to multiply by a negative 1/3. So I'll multiply this by a negative 1/3. What does that do? That changes it to less than or equal to. Okay, and so this is going to give us x, and now here this is going to go in here once, that's going to go in here 5 times, so it's going to give us a negative 5 halves. Now, what about this one? Well, here again, we're going to add 6. We're going to add 6. And I have to multiply by 2 over 2. So that's going to be 12 minus 3, which is going to be 9. So it's going to be minus 3x less than or equal to, and that's going to be a positive 9 over 2. All right, again, I'm going to multiply by a negative 1/3 like I did here to get rid of this. Those will cancel. And so I'm going to multiply by a negative 1/3 there again. What does that do to this? Well, that makes it greater than or equal to. And 3 goes in here once, 3 goes in here 3 times. That's going to be a negative 3 halves, and that's going to be x. And so now, that's going to be negative 2.5, so that's going to be smaller. And negative 3 halves is going to be bigger. And so it's going to be less than or equal to this one, or greater than or equal to that one. And because it's or, we're gonna have to include all those points. So it's gonna go from negative infinity to negative 5 halves with a bracket, union, bracket, negative 3 halves to positive infinity. Okay, and so all the numbers within this area or in this area should give us a true solution for that inequality. All right, one more here. That's going to be the last one. So first thing I'm going to do is I'm going to add 3 to both sides. So that gives me a negative 2 absolute value of 4x minus 5, and that's going to be greater than or equal to 4. Now I'm going to divide by negative 2, divide by negative 2. When I divide, that's changing that to less than or equal to, and here we have negative 2. Here we still have the absolute value of 4x minus 5. All right, with the less than, it's going to give us the tripartite. So that's going to give us, well, opposite of negative 2 is 2. And that's less than or equal to 4x minus 5, less than or equal to a minus 2. So I'll add 5. And so it's going to give me 7 is less than or equal to 4x. And that's going to be less than or equal to 5 minus 2 is 3. Now divide by 4. And you know what? We have fractions again, but it really doesn't matter because all we have to know is which one is bigger than the other one. So 7/4 is less than or equal to x is less than or equal to 3/4. All right. Well, 7/4 is definitely larger than, let's rewrite that maybe here a little bit. And 3/4, there we go. And so it says x is greater than or equal to 7/4, so that's greater than or equal to goes that way, and less than or equal to 3/4 goes that way. And because we have tripartite, we have to have intersection. There's no intersection, so there is no solutions. Okay, so okay. And so that's all I have for this section, and hopefully that will help you get through the homework.